Hey guys, so today we're going to be doing an LS400 from a 98 to 2000. That means it's a 1UZ-FE VVT-i, and this one's retaining the 5-speed auto box. So let's get into it. Right, as I said, this is going to be a LS400 98 to 2000, so 1UZ-FE VVT-i, and retaining the 5-speed automatic gearbox. What you guys probably have noticed is over here you can see a bunch of long wires that are all bundled up together there. This is actually going into a rock crawler in Germany. So the engine's being mounted in the rear of the vehicle, with the ECU having a mounting place sort of up here at the back of the engine on the frame. But obviously we wanted things like the fuse box and everything to be at the front of the vehicle. So what we've done is we've made a 2.2 meter long extension. So you see the harness comes off there, goes into a 2.2 meter long extension there. All the body plugs come off there, and again have a nice 2.2 meter extension to move the fuse box into the front of the vehicle, where it can be mounted by all the switches, etc. Okay, so what we're going to be doing today is the usual. If you watch our videos, first we're going to go through the layout of the entire harness, explain everything in detail, go through the plugs so you know where to connect everything. Once we've done that, then we're going to go to the testing. Again, as per usual, testing with the ignition on, testing with the engine running itself, and then we'll be done with that. So, like I said, before we go ahead, I'm literally going to take you through the whole build process. Obviously, this one involved quite long sections of harness, so you'll see some nice new harnesses built there as well. Obviously, we've stripped the harness down, removed everything that wasn't necessary, left in everything that was necessary, and added all these extra bits on, like the fuse box and everything, to make it a standalone harness. So let's do that now, and we'll be back in a second. Right, so there you go. You can see all the new stuff we've built, how we stripped the whole harness down. We've checked everything over, replaced all broken connectors, any terminals with broken wires. We've cut them off and replaced them with new terminals, etc. as well. Right, so as I said, let's get into the layout of the harness, and let's start right here at the ECU end. Okay, so again, with the ECU, it's super nice and simple. You've got 1, 2, 3, 4, 5, 6 plugs. Okay. 3 of these are what I refer to as the body plugs, so they would go into all of the body control item stuff that needs to be controlled. And in our case, what we do is we take all of those, and again, 2.2 meters, and they go into the fuse box over there. In this case, we've actually got 2 connectors. So you can see down here, this is the 21 pin, and that goes across to the 6 pin over there. So 2 plugs that are coming from these body plugs over here in the case of an auto, and they go straight in there. Now, all of these plugs are unique, so obviously you can't get it wrong. You can't plug it into the wrong place, so that's great. Also on the fuse box, all the plugs are unique, so you can never plug the wrong plug into the wrong place, okay? So no need to worry about knowing about where everything goes. It'll determine itself effectively, okay? So those are all your ECU plugs there. Ignore this one. This is just for the testing purposes over here. And then also coming out here is just a 3-pin DTM plug, because we couldn't actually fit all the wires required in this fuse box with the plug setup that we currently have. So there's just 3 wires here that we take across straight from the harness, and they go straight into the body section there. So again, the reason we put a connector here is obviously to make it detachable. So if you wanted to remove the engine harness, you unplug that, you unplug those 3 over there, and you unplug that, and then you can pull the entire harness out of the vehicle and everything else like the fuse box and the body plugs, they can all stay behind in the vehicle, be plugged back in when you put the harness back in. Right, so moving up there, we then end up with this breakout point over here. That's where this section goes to over there. So again, we're using, as you can see, the existing wires and putting them into our own connector. And from this, we've made then a 2.2 meter extension, and that goes all the way around to there. And again, same principle, all the plugs are unique. You can't plug the plug into the wrong place. What you could technically do if you wanted to, you could actually just plug this directly into there. But obviously in the case of this particular vehicle, they need that 2.2 meter long extension to reach to the front of the vehicle. Okay, so that brings us to over there. Then obviously this little junction box over here, which we just go there. Now what I have done is normally I would tape up this rubber grommet here, but in this case I haven't because it's such a unique vehicle. And obviously, like I said, the way they've set it up is the ECU's got a bracket, which is about here. So again, I don't know if they want to move this up a little bit or actually extend it down a little bit. I'm not quite sure what their setup's going to be. So I'm kind of leaving that loose to give them the freedom to move this to wherever they need to move it to. Because obviously this has got to go into the frame somewhere, then that's got to go round, and that's got to then plug into the ECU over there. All right, and then obviously all the body stuff just makes its way to the front of the vehicle. So that's why this is looking loose. It is on purpose. It's not a mistake. All right, so following up along here, as you'll see, this is for a left-hand drive vehicle. Like I said, it is in Germany, so this is a left-hand drive vehicle that this originally came from. But once we get down to the plastic over here, it then splits up to go forwards, goes around the back, and makes its way over there. So what we're going to do first is we'll go to the section over here, because there's a little breakout, there's a little section coming out here. And then what we'll do is we'll make our way over the front over here, and then we'll go over the other side, carry on around there, and go along to the front of the vehicle. So as you can see here, there's just a little breakout there, and it goes to the earth strap. So again, this is a 1UZ VVT-i, so we're using the M8 bolts over here, not the M6 bolts that are over there. Okay, that's pretty much it that's coming out there. So we'll go back over to here, and you'll see the plastic is there. Now the plastic does mount in a couple of sections. So I've got the bolt here. So remember, this is a 3UZ engine from an LS400. This is not a 1UZ VVT-i. So some of the mounting points for the 1UZ VVT-i harnesses are not present. So you'll see that this one is the same between a 3UZ and a 1UZ VVT-i. But this one over here is not. But if you actually take a look, you'll see where they left the casting mark there for a mounting point for there. And then the last one is on the inside here. So on a 3UZ, this is where the water pipe comes out. See if we can get it in focus. That's where the water pipe comes out. Obviously, I've welded that up. So that would be a mounting point for the 1UZ VVT-i. And that's the difference, because you see the 3UZ one mounts over there where the screw is. Let me get my hand out the way to see if I can. There you go. You can see the screw down there. Sorry, bolt, not a screw. You can see the bolt on there where the 3UZ plastic would mount to. Okay, so just a useful bit of information. If you are putting like a 1UZ on a 3UZ, or you're getting a water bridge from a 3UZ and you've got a 1UZ VVT-i, yes, they will fit. But obviously, if you put a 3UZ on a 1UZ VVT-i water bridge, this is what's going to happen. You're going to lose 2 mounting points. You could possibly drill that one out over there and tap it. And in which case, I think that's pretty secure with 2 mounting points, which is actually what the 3UZ has only. It's just using that one and that one over there. So, all right, so that's just a little tip for you guys if you are looking for parts and guys are offering parts to you. So, moving along here. Now, just before I start, the way you look at the engine and the way I'm going to describe things is always from the driver's perspective. So, looking at it from the back, okay? So, this is going to be the right bank. That's going to be the left bank. So on your right bank, you've got cylinder 2, 4, 6, and 8. On the left bank, you've got all the odd numbers. So you've got 1, 3, 5, and 7. Okay, so I'm going to go through them all and say that's injector 2, that's injector 4, that's injector 3, etc. But just in the beginning, so you guys know what I'm talking about. So in this little plastic section, first thing that pops out is going to be injector 8 and coil 8. Okay, then it moves up along here and has a second breakout point over there. That then goes to injector 6 and coil 6, but it also breaks out and goes to the ACIS system. Now, ACIS, or acoustic control induction system, you could call it variable intake runner length if you want to give it a really long name. But I do have a video explaining how that works, and I actually pull apart an intake and show you what's going on inside. That will be linked down in the description. I've got a load of videos in there that you guys can link to, and I explain a lot of things like fuel pumps and how they work and ACIS and etc, etc. So I do advise you, go down in the description, have a look at those videos. A lot of useful information for you there. Right, moving along, the harness is going to break out here again. Now, what I will tell you is if you just look over here, you'll see there's a screw hole there and there's a screw hole there. Now, I just put this P-clamp on just to give you guys sort of an indication of what you need to do or what you can do to keep the harness in place. Obviously, I need access to all of the injectors to pull them out one by one for the testing. So I haven't bolted it down here because I need that flexibility to move it up. But yeah, ideally, you would then just use that screw hole there and use a P-clamp to bolt it down there and use a P-clamp to bolt it down there and keep it in place. All right. Anyway, coming back here, this breakout over here is going to go to injector 4 and coil 4. It's also going to go to the cam sensor for the right bank, or VVR as Toyota call it. Now, the reason they call it that is it's actually measuring the intake cam. So if you pull open the cam cover, you'll see there's 3 teeth on the intake cam on this one. So remember, this is a VVT-i engine, but it's only VVT-i on the inlet cams, not the exhaust cams. The newer GRs and URs and all of those are obviously VVT-i on both the exhaust and the inlet, but these older ones are just on the inlet. Okay, so this is measuring the cam on the inlets. On the right bank, we'll have one on the left bank, and effectively you can see what they're doing. It's basically just telling the ECU is commanding a certain degree of either advance or retard on the cam, and that's then measuring that, and then the ECU can say, yes, whatever I'm commanding is what I'm seeing. Okay, nice and simple. All right, so that's that breakout over there. Then it moves forward to the front here, and we have a breakout with quite a few things, so let's delve into that. So first of all, we've got injector 2 and coil 2, nice and simple. We then have our coolant temperature sensor, so that's our 2-wire sensor over there. Then in this case, what we've got is we've added our own temp wire. Now, if you've watched all our videos, you'll know what that means, and basically there's a wire coming out of the fuse box over there, which is actually connected to my device. So we put this in for you guys so you can fit your own coolant temperature sensor for whatever dash or gauge you are using. So it's just like a convenience thing basically, because it doesn't happen on the 1UZ VVT-i. They communicated the coolant temp like the LS400 via multiplex, and that's how the information was received. Now, you may notice I've got a coolant temperature sensor in there. If you look at your engine on a 1UZ and a 3UZ VVT-i, now I must be careful because on the 1UZ VVT-i, there were some Japanese models that did have a temperature sensor in there. So basically you'll see there's a bolt that you can then take out. So you take out that bolt and you can screw in your own coolant temperature sensor. Now in this case, I've used a 1UZ non-VVT-i coolant temperature sensor, the single wire one. And basically I've just stripped the end of that wire and pushed that into there. So I just want to test for my purposes that I'm seeing coolant temperature coming through, and that wire that I'm going to go through in a minute is connected correctly. All right, so that's that. Also coming out here, we then have our MAF sensor wire. So again, this is a 1UZ VVT-i MAF, so it is different from a 3UZ MAF. And just so you guys know, you'll see there's actually holes in this side, and if I flip this 180 degrees, you would see it's actually a blank face on the other side. So remember, holes facing towards where the air is coming from. Okay, so that's where the air is basically going into those holes so we can measure airflow. Okay, right, so the wiring between this and the 3UZ style one. So again, I must stress that there were some 1UZ VVT-Is that came with the, what I call the 3UZ style, the much smaller one, basically the one that looks like that, okay? The wiring between this sensor and that sensor is completely different. If you were to plug this plug into one of those sensors, okay, and power it up, I think if I'm not correctly, it's to do with the intake air temperature the wrong way around. So basically you force feed 12 volts down the intake air temperature sensor. So usually you end up breaking the particular mass airflow sensor. So again, guys, be super careful. Make sure that you got the correct mass airflow sensor for your engine. Down below in the description, I've also listed a bunch of parts and part numbers for stuff like the mass airflow sensor, stuff like the Lambda sensor, etc. I've also given some Denso part numbers for the Lambda sensors because they're obviously a little bit cheaper, but because they're Denso, they're still OEM quality because that's who makes them for Toyota anyway. So I have given you those part numbers down there. Okay, so that is the mass airflow sensor. Be super careful. If you're not sure, check on Toyota DIY. Put your ECU part number into Toyota DIY. That will then bring you to the vehicle. Once you've got the vehicle, then you can go into the airbox, which is where the mass airflow sensor part number would be. And you can double check that to make sure you've got the correct mass airflow for your ECU and therefore the wiring. Okay, but like I said, it gets confusing because there are some Japanese models that came with the small style mass airflow sensor. All right, so again, just double check. It takes you 5 seconds and you can save yourself a mass airflow sensor. All right. Also coming out here is then going to be our oil control valve. So there's our oil control valve. So oil control valve for the VVT. So obviously the cam timing is controlled by oil pressure, and that's the solenoid that is there for controlling the cam and what position it is. All right, so that's that connector over there. Moving down over here, and then we break out at the bottom here, and you'll see this is part where we've now added in wiring, because the alternator harness on a 1UZ VVT-i LS400 is not actually part of the engine harness like it is on a 3UZ. So you can see that's all labeled up there as alternator because we've added that into the harness, okay? I think maybe the GS400 1UZ VVT-i, I think that is a different one, which is the same as the Crown. And I think all of this alternator stuff is included in the harness with those particular setups. And obviously all the 3UZs have the alternator included in there. Anyway, so yeah, we break up over here, and then the last part is we come down to here, and then we have our Lambda sensor at the back over there. Now, quick note, we're not using the secondary Lambda sensors, and I'll explain that all in the diagnostics when we get to that stage. But yeah, no secondary Lambda sensors are being used. We're only using the primary Lambda sensors in this particular case. Right, so that's this side completely covered. Let's pop over to the back there and carry on over to the other side. Okay. Right, so focusing on the piece of plastic over here, you'll see it carries on along there. What you'll notice as well is you've got a plug in the middle here. Now, this is not what your plug would look like. This particular customer didn't send us the harness that went under the inlet manifold to the starter motor and the knock sensors. So we don't have that section. So I've just created my own little one to go to the starter motor just so I can crank the engine over and start it. All right, so what you'll notice is even though I am running the engine, even if the knock sensors are not connected, they don't come straight away with a fault. And usually on these ones from memory, they don't actually come with a fault until you actually put the engine under load. So even me revving it here on the test bench doesn't cause the check engine light to come on for the knock sensor. So something to be wary of there. All right, so that's that plug over there. And then we move along down to here, and then you'll see we've got a section that breaks out at the bottom over here, okay? So let's go through what's coming out there. So first of all, you can see there, we've got our earth. And again, we're not using the M6 bolt, we're using the M8 bolt. And if you have a 1UZ VVT-i, you won't even have this bolt there. You would only have this bolt over here, okay? And next up is going to be the gearbox harness. So that is going to be down here. And you'll see there, it breaks out into 4 sections over there. So one of them is going to be to the input speed sensor. So again, this goes to the front of the gearbox on the left bank side. Then you've got that section that pops over to there. And that's going to be our solenoid plugs. That's at the back of the gearbox on the left bank side. And there's the output speed sensor. So again, that is going to be on the back near the solenoid plug over there. And then lastly, this section coming out over here, that is going to be your selector plug. Now, I don't have a 1UZ VVT-i selector in stock. I have a 3UZ one, which I took from this engine. So basically, I've adapted from that to that. And that's going to then give us all our gear positions as we should have it. Okay, right. So that is that section over there. And then lastly, coming down over here, we then have our Lambda sensor that pops out over there. All right. So as you can see here, in your standard car, there's actually a metal shield that goes here. Now that's pretty important because that protects your connector from the exhaust. So again, I must stress to you guys, you do need to put that metal shield back, okay? Do not leave that shield out, because if you do, there's every possibility that that connector is going to end up touching on your exhaust. It's going to end up melting. And there is a 12 volts and a ground in there. So what's going to happen is you're then going to short that out. And that is the same system that supplies like your MAF and everything with it. So once that goes, your other Lambda sensor is going to go, and your mass airflow sensor is going to go, and your ACIS is going to go, and all of that, because that's all powered from the same, what we call the sensor 12 volt circuit. Now, it is a bit different in the original car. I separate it more in my fuse box because it helps with diagnostics, and it doesn't always shut down everything when you do this. So I split things up a little bit more than what Toyota would in our fuse boxes for diagnosis. Right, I'm just going to quickly check and see what's happened. I think the light's gone off on my phone, so I'm just going to pause here for a second and we'll be back. Right, so it turns out my iPhone flash causes the phone to overheat. So yeah, might be some couple of little cuts every now and again, just so as I let the phone cool down. Anyway, so we've gone through all of that now, so that's gravy. So what we're going to do now is carry on here. So again, you plastic ends over here. Harness then comes up over here, crosses over the fuel pulsation damper, not regulator, bear in mind. And then we enter the piece of plastic over here. And you have 2 mounting points, one over there and one over there. So 2 bolts, really, really nice, simple and straightforward. Okay. Right, so one change that I have made on here is that basically we change where coil number 7 comes out. So usually coil number 7 comes out there and then stretches across to there. but it did cause a bit of confusion, and I had a guy that actually swapped these coils around and caused issues for ages. Obviously, we couldn't find the misfire. All it was just these two swapped around. So we've taken injector 8 and coil 8 and bought them both out of here. Now, this is actually the same as the way the 3UZ did it. So I'm pretty sure that Toyota actually came across that same issue in their workshops. Hence the reason why they changed it to like the same way on the 3UZ, where the injector 7 and coil 7 came out of this section over here. Much better way because it helps you determine exactly what's what, and it's nice, easy 3 sections that break out there. So that's the first one. Coming down over here, and then we go to injector 5 and coil 5. Super simple and straightforward. Moving along to the front here, we then have injector 3 and coil 3. And then we have our cam sensor for the left inlet cam. So again, the same explanation as the one that's on the right there. This is just the left-hand one measuring the inlet cam over there. Right, then coming to the end of the plastic, and you'll see the harness carries on along here. Now, one thing that does pop out along there is going to be your noise filter connector, okay? So your noise filter is a little gray thing. It's bolted onto the inlet manifold, usually about there or so on and so forth, and it just plugs straight in over there, okay? A noise filter is effectively just a capacitor. So when you bolt that down to there, the reason there's only one wire in there is because it's earthing through the inlet manifold, and then it's supplying 12 volts. That 12 volts wire is the same 12 volts that goes to your injectors and your coils, and effectively it reduces the noise. I think it's, sorry, in this case it goes to your coils, but in the Toyota way, I think it all comes together in the end. But obviously in this particular case, in the engine harness here, this is going to your coil 12 volts. And the capacitor then absorbs any type of spikes in voltage, etc., that occur when the coils are actually firing, and it's requiring that energy to do so. Okay. Now, obviously, the reason they do these on here is a couple of reasons. Number one, as I've discussed before, obviously it stops the hissing on your radio because that's caused by electric interference. And also, as Calvin did a video on as well, it does reduce the noise in the system. So all of your shielded cables for your cam sensors and your crank sensor and your Lambda sensor, they are all shielded, which means they're covered in a metal jacket that effectively absorbs all of that electrical noise and interference, and it drains it back to ground. Okay, that's what that little orange thing down there is. You'll see there's a bunch of grounds in there, and if you had to look closely, if I untape all of that, you'll see all of the shielded cables have a ground coming off of them, and they all attach to power ground, or basically one of these two rings on the cylinder head there. So again, any electrical interference that goes from the harness through that will then be absorbed by the ground, by the shield, which will then drain off to ground. So okay, so it reduces the noise that ends up in your sort of sensitive signals like your crank and your cams and your Lambda sensor, etc. Okay. Obviously, if you don't have it, I've run the engines without them without any major issues. But if you've got it, again, go ahead and plug it in. Now, there was actually a question on Calvin's video about a customer of ours that we built him a brand new harness, and was obviously asking the question about these noise filters. Now, when we build brand new harnesses, unlike this, but as you'll see from those build photos of those harnesses there, we obviously considerably twist all of them. Now, what you'll notice with the shielded cables as well, they also do the same process. They twist them together, and the reason that is because if you twist the wires together, whatever noise or interference is affecting one wire will affect the other wire in exactly the same way. So the best way to describe it to you would be if you had a room and you had a speaker on one side and a speaker on the other side, and you played the exact same wavelength of sound. If you had to position yourself, which is obviously very difficult, but I'm talking about theory here now. If you had to position yourself dead in the center, those two sound waves would collide and basically cancel each other out, and you would end up with effectively a completely dead spot where there is no sound. Now, that same principle applies when you concentrically twist. Obviously, any noise that was going to affect a wire, the other wire, whether it be the sensor, ground, or whatever, is all twisted in pairs like that, and they're all twisted together. So whatever noise affects one affects the other equally. And if you affect one wire and the other wire equally, they cancel each other out. Okay, so that's why you'll see on concentric harnesses and so on, you won't find these noise filters on there, because it is not really necessary, especially with aftermarket where you can filter out any type of noise. But if you are building them like this, where you just have straight wires running through, then it's definitely a good thing to do. Just avoid any type of noise. The other thing you can do if you guys are building your own harnesses is to avoid noises, to make sure that your grounds are incredibly short. Hence the reason why Toyota have a ground there and a ground there, and that is basically because they're grounding the coils as quickly as possible to ground. Okay, so remember, your engine block is a ground. It's a big ground as well as your chassis. Okay, so that's why they have like an earth that would normally go from here to the chassis, and then obviously they got one from the block going to the chassis and the battery as well. So again, if you can ground your wires incredibly quickly, or as short as possible, that is also advantageous in that particular thing. So don't always run your grounds like miles away. If you use a star ground principle, which means you create one star point where you ground everything from, make that the engine. And then that way, any grounds you take straight to the engine. Sorry, just a little tip for you guys while we're here. All right. But anyway, that comes out over there and it'll plug into the noise filter, which would normally on the inlet manifold there. But moving along to here, and it breaks out of the front here again, and it goes to injector 1 and coil 1, straightforward. It also goes to the oil control valve for the left bank, okay? So those are the 3 sections that pop out over there. Then a little bit further along here, we then pop out to this. This is actually the TPS plug. What I mean by that is, what Toyota did is they created a sub harness, because there's your TPS down there. And if you take a look at the bottom there, there's your connector. I wonder if I can touch it there. There's your connector for your TPS. Now, as you can imagine, trying to undo that, take the harness off, would be incredibly difficult. So they created a little sub harness there and it plugs in there. So from the engine harness, that just plugs in there. So that's your TPS plug, okay? Also coming out of there is this long one that stretches all the way across over here, and that goes to your accelerator position sensor, okay? So this is drive-by-wire. There's plenty of videos on that. Both myself and Calvin have done a lot of videos explaining exactly how it works, but a quick brief explanation. This is just an accelerator position sensor. You can see I'm not even moving the throttle blade, but if I get to the very end, okay, so it was this was their first delve into drive-by-wire. They wanted to have like a override feature. So in other words, if the throttle shut itself down, you could still pull the accelerator pedal, which would be attached to a cable, which would be attached to the accelerator position sensor. And then it would allow you to open that throttle just a fraction at the very end of the accelerator there, which would allow you to get home or the workshop or wherever it was you were going to get the situation resolved or looked at, okay? So remember, this is your drive-by-wire motor, that's your accelerator position, that's your TPS, okay? Drive-by-wire. Right, moving along from there, it's going to travel underneath the throttle body over there, and it's going to break out just about there. First one it breaks out to is your drive-by-wire motor plug. Now, obviously, you might say, Chris, there's 4 wires. A drive-by-wire motor only has a positive and a negative. Well, this can often be referred to as what they call a clutch system. So any of this era of Toyota drive-by-wire that usually had the accelerator cable also had a clutch. So 2 wires are for the clutch, 2 wires are for the motor. So the way that Toyota would do it is if they needed to cut the throttle for whatever reason, safety reasons, the clutch would actually deactivate. So the ECU had like a master override where it could literally undo the clutch, unpower the clutch, and this motor then has no connection to the throttle body whatsoever. So they wanted to shut the throttle down super nice and easy, which is sometimes when you hear the throttle shut on these, you can actually hear it like click, and then boom, you'll actually hear the blade shut closed. Okay. Also coming out there is going to be your cam sensor for the front. So again, this is not the same as the ones that are in the inlet cams at all. This one is just picking up a single tooth that is on the cam pulley underneath this one over here. So this one the ECU uses for engine position, because obviously it's a static position on this one because it's actually attached to the timing belt. And so this one tells the engine what position it is in terms of the 720-degree cycle, okay? So single tooth on this one, 3 tooth on the cams in the middle, and the 3 teeth are different sizes. They refer to as medium, small, large. Anyway, so we're moving along down here, and you'll see there's a mounting point there and a mounting point there. You should have a bolt on there with a clip to hold this cover on. But anyway, don't mind my clips, just temporary ones, so it's nice and easy to take the harness out every single time. And we come down to about here, and then the harness breaks out again into 2 sections, okay? So this section, which comes through over here like this, all right, that is your oil pressure switch. So again, this is something that we've added into the harness. Sorry, the sun directly behind me here. This is the one that we've added into the harness, hence the reason why it's covered in heat shrink and labeled and everything like that. So with the 1UZ-FE VVT-i, both the alternator and the oil plug, among others, came in a harness that ran underneath, which also contained the main power cable for the alternator as well. And so what we do is we take those connectors and we add them into the harness to make it like a 3UZ, which had both the alternator and the oil pressure switch included in the engine harness, okay? And the last section is going down there, and that's going to go to your crank sensor over there. I'm going to try and give us some shade so we can see. And that's your crank sensor over there. Super nice and simple. What you might want to do with your crank sensor, guys, just so you know, it is a magnet because it's a variable reluctor sensor. You can actually unbolt this. If it's a little bit tough to take out, I'd probably soak it in WD-40 for a while. They can get very sticky. But obviously, as your timing belt wears over, over use, they'd actually put some metal, like sort of shavings in there. And this sensor can actually get covered up with metal shavings. So it's not a bad idea just to undo this bolt, take this out, give it a wipe, get it nice and clean, put it back in again and bolt it up as well. Also, while I'm here, this is an LS400 engine. So this has the oil filter housing pointing towards the front. In the case of the customer, they're LS400 VVT-i. So their oil filter is going to be about there, and their oil pressure switch is going to be there, but actually facing that way, which is why the oil pressure switch breaks up over there and not over here like it does on a 1UZ LS400. Okay, because remember the GS430 and the SC430, the 3Z 5-speed models, they also had the oil filter housing that was there, not there. Okay. All right, so that's this section all now completely done. That basically covers the entire harness layout. Hopefully that was super useful, again, for the customer that's fitting this, but anybody else that wants to know how the harness routes on these engines, that's a really nice explanation of where everything goes. Okay, so now what we're gonna do is we're gonna move over and we're gonna start looking at the plugs, or basically the 2 plugs on the fuse box that the customer needs to connect on their side. Now, we do have the 9-pin plug, and if you've watched any of our other videos, this is going to be a massive repeat of what you've seen before. And then we have the other plug over there, which is the 15-pin connector, and that has most of the gearbox stuff or gearbox related stuff, as well as the OBD2 connector, which you can see over there, which I'm plugged into. Okay, so let's get started on the 9-pin plug so we can go through that. Now that is red. Now it's actually out in this particular case because obviously I've got it now connected directly to the battery, okay? And that needs a permanent 12-volt supply. So I'm going to explain this to you so you understand exactly why I say that. Effectively, that is a power to the ECU to help it store codes, to store data like long-term fuel trims, etc. So if you connect that wire to ignition 12-volt supply, so in other words, it cuts power every single time you turn the key off, you're effectively going to be resetting the ECU every single time. So these are not one of those ECUs where you have to disconnect the battery for 10 minutes for it to reset. The second you cut power to the ECU, it resets everything. It happens immediately, okay? So the reason we say to connect that to a permanent 12-volt supply is so that you can store codes, store data like long-term fuel trims, throttle learning, etc., etc. And that's super important because when you're trying to do diagnostics on this particular thing, let's say you're driving along, your check engine light comes on, you're like, great, that's cool. You come to stop at your house, you turn off the key, you then plug in your diagnostics machine into your OBD2 port that we've provided. You then put the ignition on, you go look for codes. There's no codes, okay? So what's happening there is every single time that you turn the key off, you're resetting the ECU, which is going to make diagnostics incredibly time-consuming, painful, and yeah, it's just going to be a nightmare to do. So do connect that to a permanent 12-volt supply. Now, let's look at the caveats. In this particular case, this is going into a race car, right? Pretty much all race cars, whatever series you're in, require some sort of battery cutoff, okay? That is absolutely fine. You do not need to connect that permanent 12 volts, okay, to the other side of the battery cutoff because you want the battery cutoff to behave in the way that you expect. You want it to shut everything down if you were to pull it or take it out or push the button or however your particular cutoff switch works. But the idea is that if you were doing some sort of diagnostics, you wouldn't keep on turning off the main power switch. You'd be turning the ignition off, you'd be starting it up, you'd be doing all of that, but that power cutoff switch would be on the whole time you were doing it, and it would allow the ECU to retain its code. So if you do get a code and you get to a stop or whatever, and you want to do diagnostics and you haven't got your machine with you, and you do have a cutoff switch, I would say, if you can, if it's possible, don't pull out that cutoff switch until you get home and you can read the codes and you can see what's caused your issue, okay? If you can't, because of whatever reason, absolutely fine, then go home, plug it all back in again, try and recreate the fault, and then read the diagnostics, okay? All right, so that's the reason why you need the permanent 12-volt supply there. Number 2 is going to be black with a yellow, and that is our black with a yellow over there. That is your start signal. It's a very simple 12-volt signal that you would give to the fuse box to activate the starter motor, okay? This does retain the neutral start switch like on a standard auto. So this vehicle will not start unless it's in park or neutral, and I will demonstrate that as part of the testing for you guys. So yeah, if for whatever reason you're trying to get it all set up and you go and it's like, oh, it's not cranking over, it's not cranking over, just make sure you got your selector switch plugged in and that it is in park, okay? Otherwise it will not start. And if you are using an ignition barrel, obviously that will give a 12 volt signal for the starter signal. So you'll be absolutely fine there. If you are using a like a push button or something like that, ignition 12 volts to the other side, and then our black and yellow wire to the other side of the switch, or push button, or whatever you're working with. Okay. Next up is number 3. That's going to be yellow green. So there is our yellow green wire over there. You can see my just finger underneath it over there. That is the temp. So again, that's the one we spoke about over here. So that's that one over there. So we just bring it inside the vehicle so that you guys can then connect it to whatever temperature gauge, sensor, whatever basically you need to connect it to on there. Okay, so if you don't need to use that, just leave it blank. All right. Next up is number 4, which is gray, and that's that gray one over there, and that is for the fuel pump. Nice and simple. You literally take that directly to the 12 volt side of your fuel pump. It's a built-in relay in the fuse box, so it is relayed. It is fused at I think 20 or 25 amps, which is plenty enough. The wire on my side is about 16 gauge, which should be more than enough. You shouldn't really see between, you should see maybe between sort of 5 and 10 amps on most fuel pumps, so you should be absolutely fine with that. If you wanted to run another power to the fuel pump at the back of the vehicle, you can always use that as a trigger for another relay that you can put in the back of the vehicle. That option is definitely open to you. Now, the fuel pump in this case is controlled via the ECU. As I said before, down in the description, I've got a bunch of links, one of which includes how the fuel systems work. I would advise you to go watch that because we get a lot of phone calls and messages saying, I've hooked everything up, I turned the ignition on, but I get no fuel pump. Well, if you watch the video, you'll understand why that is completely normal and nothing to worry about. Okay. Next up is number 5, and that is our yellow-red, which you can see over there. And that is our check engine light, which I currently have connected to our cluster over there. Now, what you'll notice is we also have LED inside the fuse box that's also connected to your check engine light. And that's just simply so that if you guys have, doing what I'm doing, have it on a bench like this and you want to start your engine up before you fit everything, make sure it's okay, no problemo. That'll act as a check engine light to make sure that everything is powered up and you're ready to start. Okay. Now that provides a ground, just so remember. I have written everything down in there, by the way, which you do get with the harness, but just so I'll show you. That gives off a ground signal, which is the theme when you see when I go through the rest of the wires here. Number 6 is yellow, and that's taco. So you see our yellow wire is actually underneath our yellow with the red over there. Perfectly fine. So again, I'm connecting it to our cluster over there for testing purposes. I want to make sure that it works. So we'll rev the engine, make sure it goes up and down. Just a heads up, that's an ACIS-300 cluster, which means it's from a 6-cylinder engine. The 1UZ and the 3UZ give off a 4-cylinder signal. So that engine RPM, when we do start it up, is going to be wrong, but that is perfectly fine. Nothing to worry about, okay? Next up is number 7. That's black with a red. So that is our black with a red wire over there in my finger. That is your ignition 12 volts, okay? So that is the wire that you do provide with an ignition 12 volts. So either from a key barrel. If you are using a key barrel, just be aware that key barrels tend to have accessory ignition start. Now, the reason that's important is if you connect our black with a red wire to the accessory feed, the moment you turn the key to start, it's going to cut power to the ignition, which is effectively going to shut down the entire system. And it becomes incredibly hard to diagnose because you put the key to start, your check engine light will go out, not because the engine is starting, but because you physically shut the whole ECU down, because obviously you connected that feed to an accessory feed. Okay, so if you are looking for the signal at the back of a key barrel, just find a 12 volts when it's in the ignition position. And second check, move the key to the start position and make sure that that 12 volts doesn't go away. If it goes away, you've got accessory, not ignition. If you are using a switch of some description, then obviously on the other side of the switch, you'd need a permanent 12 volt supply, obviously. And the other side of the switch would then go to our black with the red one. That would be, here come your ignition switch. Okay. Next up is going to be pink with the blue, number 8. So you can see I've got pink with the blue over there. It's going to my little device over there because that's translating MPX for the alternator light so I can do my testing or whatever. So anyway, that again is an earth signal. Now something to think about if you guys have older vehicles. What tends to happen with older vehicles is the actual dash supplies the 12 volts because the pink with the blue supplies the ground. Okay, that's how your light turns on inside for your battery light. Now, on these newer models, they always put like diodes in so you don't backfeed into the system. On the older ones, they don't. Okay, so that's something to be very, very careful of. So what can happen is, I've seen it many times in the past, is actually the cluster backfeeds through that, which then backfeeds into the alternator, and the alternator has an ignition 12 volts and a permanent 12 volts supplied to the regulator over there. So What will happen is it can sometimes backfeed there, backfeed into the fuse box and keep the system alive. So turn the key off, hey ho, guess what? Whole system stays alive. If you are having that issue, then just put a diode in the system. Or what you can do if you want is, if you have an old cluster, see if you can get some LED bulbs for it, because an LED is a light emitting diode, so it'll stop the effect that you're having there of a backfeeding through the cluster. Okay. Next up is number 9, that's yellow with a black. So again, my yellow and a black is going to the same little device, because that's going to translate the MPX to then cause my oil light to come on, again for testing purposes, to make sure that it all works. It just looks neater and nicer on the cluster there. And again, that is giving out a ground. It doesn't go to anywhere else. It literally comes straight from the oil pressure switch at the oil filter housing, and it goes straight to that yellow with the black wire. Same with the alternator wire. It literally goes straight from the alternator straight to that pink with the blue wire. It doesn't go anywhere else, okay? It doesn't go to the ECU at all. Okay, so that is our normal 9-pin customer plug. Really simple, really straightforward, nothing too complicated. One thing I did want to bring up, because obviously there's a lot of things in there like Coolant, Temp, and so on and so forth. Obviously there's a major popularity or rise in popularity of these dashes that use OBD2 to get all of the data from your ECU to then transmit to a dash. Now, one thing I do want you guys to be aware of when you are looking at that is they don't always tell you that they only work via CAN. Again, CAN is kind of like an industry standard protocol. Anybody can know what it is, and the OBD2 is an industry standard protocol. It's the same between all manufacturers. So if you're building a dash, the best piece of data is to CAN data, because it'll be well documented and you can just write your own CAN stream, stick it in your dash, and it'll retrieve that data from the ECU. Right. Now then, therein lies the problem. If you have a 3UZ 6-speed, that's CAN. Fantastic. It communicates to the OBD2 port via CAN. You can plug in one of those dashes, no problem whatsoever. When it comes to these older ones like the 1UZ VVT-i and even the 3UZ VVT-i 5-speed, they don't use CAN to communicate with the OBD2 port. They use K-line communication, okay? Now, that's where the problem lies. If you buy a dash that says it communicates via OBD2, please make sure that they accept the protocol that would be given out by the ECU, okay? 3UZ 6-speed onwards is not a problem because it's CAN and it'll work straight away out of the thingy. You can even use one of those Haltech dashes like that over there on 3UZ 6-speed, because again, it will accept the OBD2 protocol and will transmit all of the data that is on the OBD system. Okay, just a heads up, because I've seen a lot of guys ask, oh, can't we use these little dashes? And I say, you need to check and see how they communicate first. Okay, 9-pin plug sorted. Cleared up about the OBD2 port to say that you can't use a digital dash. Let's move on to the 15-pin plug. And down at the bottom here, 13, 14, 15 is just OBD2 connector. So I'm going to write that off now quickly. We don't need to go through that at all. It's basically just there. You plug your OBD2 port in, no problem at all. Okay. Let's start with number 1, which is red with a blue, and that is reverse. So here is my red with a blue, and that'll give you 12 volts when the gearbox is in reverse. So that's obviously for your reverse lights, if you want to use that or you need to use that. Next up is number 2. That's going to be yellow. Let's find our yellow wire over there. There it is. And that's going to be PWR mode. So what I mean by that is if you look at an original LS400, even from the very first ones actually, there's a PWR switch on the shifter, which puts the ECU into like a power shifting mode, which is supposed to hold more RPM before changes, etc. That's what that wire does. Now I do write in here that needs to be supplied a ground or an earth to put the gearbox into PWR mode. We are actually going to show you that as part of the testing as well. I can actually see the data on there. It'll tell me whether PWR mode is on or off. We're going to give that wire a ground, and you're going to see it go from off to on and then back to off again. Okay. Underneath that is black with a yellow tracer. So again, nice and simple. There it is, black with a yellow tracer. That is snow mode. Okay, so if you take a look at those switches, you press down to go into power mode and it actually sits in position. And then you would flick it 1 to go back to normal. And then what you'll notice, if you've never been in one before, you probably won't know, but when you go to press snow mode, it goes down and then it flicks back. So it's what we call a momentary switch. It's not a latching switch. So therefore, what you'll notice down here on snow mode, I said that it requires a momentary ground earth connection to put the ECU into the snow mode. So snow mode is supposed to reduce your throttle opening, reduce your torque, etc., to help you pull off in slippery conditions. Okay, So yeah, you can put it into snow mode via touching that wire momentarily to that. Now, also what happens with snow mode, if you have an original vehicle, you'll know that if you put it in snow mode and you turn the key off and turn the key on again, it's no longer in snow mode. Okay, so it automatically comes out of it. But power mode is an actual switch that you can go click and it stays in position and it'll continue to keep the ECU in power mode until you actually flick that switch off. Okay. Next up is red, which is going to be 2. So there is my red wire over there. So again, that is supplying 12 volts when the gear selector is in position 2. Now, the astute among you might have noticed I've only got 2 LD and 4. I haven't got park, neutral, etc. on there. Now, one is we just don't have any more space in the fuse box to bring the wires through, to be brutally honest with you, and no one ever uses that particular information as far as I'm aware. I stand corrected if you do, comment down below. But basically the reason I've got 2 and L and D and 4 is because the way that the system engages 4 and it engages L. Now, if you look at the physical mechanical movement on your selector for a 1UZ VVT-i and a 3UZ VVT-i 5-speed, you'll notice that it goes park, reverse, neutral, drive, then it goes sideways to 4, then it goes down to 3, down to 2, and then it goes sideways to L. So 4 and L are actually electronic signals. They're not physical mechanical movements in the shifter, okay? And the way that Toyota do it and make sure that it works correctly is if you look at the diagrams, you'll see that 2 and drive end up going to the shifter. They call it shifter ECU, but it's pretty basic. But effectively, they take 2 and they take drive, and then they take 4 and L out of there, and then they feed it back to the ECU. So that's the reason we've replicated the same scenario. So when it comes to 2, you'll see it says this wire gives out 12 volts when the gearbox is in second gear. This wire is used to supply L with 12 volts, okay? So what we want you guys to do is replicate what Toyota have done. And what we mean is if you have a shifter, or if you're going to use a shifter from an LS400, you can then just connect up all 4 wires as Toyota intended, and I can help you guys with that, no problem at all. But if you have a shifter that only has park, reverse, neutral, drive, 2 and L, okay, like the old 4-speed versions, very old 4-speed versions, you can still use 4 and L. You just need to use switches, and your selector will no longer be park, reverse, neutral, drive, 2 and L. It'll actually be park, reverse, neutral, drive, 3 and 2, okay? And so effectively what you can do is you can take 2 to one side of a switch, and the other side of the switch you can take to L, and you can call that switch L. If you are going to do that, I would advise making it like an LED of some sorts. The reason I say that is because if you are using separate switches, we're all forgetful from time to time. So you may activate 4th because you're towing a caravan up a hill and you need to gear down from 5th to 4th. So you'll basically put the shifter, you press the button to go into 4th. It'll gear down from 5th to 4th, and then let you drive 4th all the way up the hill. Problem is that you'll forget about it. And you'll keep driving, you're going, why am I doing 4,000 RPM on the motorway at 70 miles an hour? Because you've just forgot the switch on there. If it's like a little LED on there that can remind you, that'd be fantastic. And then again, you can just flick that switch off when you want to use drive, which will give you all 5 gears. And the same applies, I went through drive and 4, but a 2 and L is exactly the same. So if you went park, reverse, neutral, drive, and in your case, 2 and L, when you're in L, you're actually 2, and you flick that switch, and then you become proper L. Low, first gear, however you want to call it, basically. That's what it's labeled on the shifter there, okay? And the reason we do that is because you can't have 3 and drive and having power at the same time. It freaks the ECU out because it goes, what's happening is not physically possible. So the way that Toyota did it is they made sure, so if you were in, let's say you got an original shifter, let's say you were in 2, okay, and you flicked your switch for L, if you just connected an ignition 12 volts to the other side of that L, if we just said to you, oh, there's your L, there's your 4, connect ignition 12 volts to the other side and feed it to the ECU, what's going to basically happen is when you're in L and you put a shifter forward, that'll put you then into effectively 3, but now the ECU sees L having 12 volts and 3 having 12 volts at the same time, and it reckons, well, that's just basically impossible. And it freaks out the ECU and she's not very happy. Okay, so that's the reason I've got 2, L, D, and 4 there, okay? It is explained in detail in there, but I just like to explain it to you in the video as well so you know what's going on. Okay, so that's gonna be our red is 2, yellow, black is L. So there's yellow, black over there. Then number 6, we've got yellow with the red, and that is yellow with the red, which is over there. And that is your kick down switch. Now, I should have put a little note there, but I know this is going to a European person, but kick down is only for Europe. not for USA and not for JDM vehicles, okay? It's only on European vehicles that have the kickdown switch. And you can evidence that by the fact that when I use my diagnostics machine, it actually gives me the option to have kickdown as something that I can see in the live data. So if you took a USA ECU and TechStream or whatever, you won't have that option. There won't be the ability to see if the kickdown switch is on or off. And again, the kickdown switch needs to be supplied a ground or an earth. Okay, nice and simple. They're keeping it simple. Every one of these things is basically working off a ground. So all your, oil lights, alternator lights, whatever, all working off a ground. So you haven't got a bunch of 12 volts floating around your car. Okay. Right, so blue and red is D and yellow and green is 4. So we've got blue and red over there. We've got yellow and green over there. So that's D and 4. Number 10 is white with a blue. So there she is over there. And that is the brake switch. So on these original cars, they used a 4-wire brake switch. So basically it told the ECU when the brakes were not pressed and when they were pressed, okay? Pretty sure it's to do with the cruise control system, to be brutally honest with you, because the IS200 manual that never came with cruise control only has a 2-wire switch. All Toyota vehicles with cruise control, you'll find, if you look at the diagrams, have this particular wire, which is called ST1 negative, which basically gets 12 volts when the brakes are not pressed. Now, we don't want you guys to have to go through all the trouble of fitting a 4-wire brake switch, so we've taken care of that for you via a relay in the fuse box. So effectively, all you've got to do now is supply 12 volts to the white with the blue. We take care of the rest. So the ECU still gets the exact same signals. It knows when the brakes are pressed and when they are not pressed, okay? And number 11, and sorry, that needs to be supplied at 12 volts. And the reason we've done that is because usually you guys are going to take a feed from your brake lights and they get 12 volts. So it is the easiest way around. Number 11 is going to be pink with the blue, which again is that one over there. And that is your cruise control. Okay, so what that means is because this particular setup is keeping the automatic gearbox, which means we have an output speed sensor for the computer to work with, means we can retain the cruise control on this particular setup. So again, the cruise control in these setups are incredibly simple. You literally just grab yourself a cruise control stalk from IS200 Auto, IS300, GS300, LS400, hell, I think even like Camrys work as well. They're basically one wire. One side goes to earth, the other side goes to our pink with the blue. And that is literally it. And you can retain cruise control on these particular devices. Now, do bear in mind that if you're fitting this to a different vehicle and you have different, diff ratios and so on and so forth, obviously things are going to change. So if you are looking at diagnostic data and you're looking at the speed that is being seen by the engine, remember that is designed for the LS400. So it's designed for X diff, Y wheels, diameter, and so on and so forth. Okay. But yeah, cruise control will work, no problem at all. Okay. So that is all the connectors that the customers need to connect inside their vehicle. It's pretty standard. And like I said, you don't actually need to connect all of it, but I try and give you as much. Like if you don't want to use a temp gauge, don't connect that. If you don't want to use cruise control, don't connect that. If you don't care about L and 4, don't connect that. You don't need to. Okay. So one thing I do want to say about the gear selector switch before, and when I go to testing, it makes it a little bit easier. But when you are fitting these in other vehicles, something I've noticed over time is if you take a look, let's go over and have a look at the switch here. I know it's a 3UZ switch, but the same applies for the 1UZ switch. But if we go and take a look over here, let me have a sit down. You'll see that's an elongated hole, okay? And the reason that is that this can be adjusted like so. And the reason that is because normally you would have your little arm, which would be bolted on here, pointing upwards, and you'd have your metal rod going to your shifter inside the car. Now, when you guys are doing swaps, and what I've noticed in the past is you guys tend to just unbolt the gearbox. You don't touch that at all. You unbolt the rod that goes from there. You then go fit it in your vehicle. You put the rod back in. However, you basically get it set up, and then you drive off, and then you have issues, and you're wondering what's going on, especially when it comes to sort of changing gears, etc. Now, what I have noticed over the past is the reason that can be adjusted is because you can go out of the range. And I'm actually going to show you when we do the testing how that works. But effectively, what I always say to people is when you first get it set up, you can use my D and my 2 and my reverse. And you can use that to determine whether or not the ECU is seeing the signal. So even without a diagnostic machine, just make sure that D and reverse and 2 are getting 12 volts when you put the selector into the correct position. Now that brings on to my second point. When you put this engine into the vehicle, okay, and you go through the whole process and you're happy, everything's rock and rolling. Remember the engine twists. So that can also affect the way it operates. So what I normally tell people is, once you're happy and it's running and everything is great and you've checked D and you've checked 2 in reverse and getting 12 volts and everything all the time, go to a safe space where you're not going to be breaking any laws, and just boot the car. Boot the car and then either attach a LED to drive or something along those lines like that. Just make sure that when you boot it that 12 volts is staying in place and that the shifter is not the rod's not moving slightly when the engine twists. Because remember, you're connecting a rod from this, which is attached to a gearbox, which is attached to a rubber mount, along with the engine on rubber mounts that can twist. Your shifter is bolted to your chassis that doesn't move. So if this engine twists or move back or forward or whatever, it can actually then cause the gear position to no longer be transmitted to the ECU, okay? So I always say to people, boot it, slam on the brakes, check that DY and make sure that she's got 12 volts the whole time you're doing that. If not, loosen that bolt, adjust it slightly a millimeter or so, tighten it back up again, repeat the process until you can boot it, slam on the brakes, and that 12 volts stays consistently on that ECU, okay? Because she doesn't like it, the ECU doesn't like it when you lose those particular signals, okay? Right, this has been a really long one, as it usually is with an auto. So I am going to get off of this. I am going to be back in a second. Obviously, I'm going to let the engine warm up a little bit as well in the background. We're going to come back and we're going to do the testing, starting off with the testing with the ignition on. So give me a second. I'll see you now. Right, guys, so we're back now. We're going to be doing the testing of the engine. So again, nice and simple, just 2 sections, one with the ignition on and one with the engine running. So let's go through what we're going to be testing and jump straight into it. So first test on our list is going to be immobilizer removal. Nice and simple. We've got our security light hooked up, which is basically what some of those wires are there for. And that's going to then turn off and put the ignition on. That tells me that the immobilizer is removed. Then we've got the check engine light and the charge/alternator light and the oil pressure light. So I'm looking for the check engine light, the oil light, and the alternator light, and the check engine light on the fuse box to light up. That's all we're looking for. Then we're going to go over to our OBD2 machine, make sure that we are getting communication from there and that works. And then next up, while we're in the machine, we're going to test the fuel pump, and that's going to be with a active test. I'm going to turn the fuel pump on. You're going to actually hear the relay click, and you're going to hear the fuel pump come on there as well. Okay, once we've done that, then we're going to be testing things for the auto, which is going to be the brake switch. So we're going to supply the white with the blue with 12 volts. We're going to test the kick down switch. So we're going to supply the yellow with the red wire with a ground. We're going to test the PWR mode by supplying the yellow wire with a ground. And I'll have the data on there to be able to see exactly what is going on and off when we expect it to. Then lastly, we're going to go to our gear selector shifter wiring. So I'm actually just going to swap the MPX signals around between my device and the ECU. The ECU will transmit the gear position via MPX to these particular dashes. So we're able to see park, reverse, neutral, drive, 4, 3, 2, and L. Okay, and I'm going to replicate that as if it was a shifter. That's with the ignition on. Then with the engine running, the first thing is to test the starter circuit / neutral start switch. So I'm going to move it from park into reverse. We're going to try and start it. It's going to do nothing. I'm going to move back into park again, and we're going to touch the black with the yellow wire with 12 volts, and the engine's going to start up and fire into life. Once the engine is fired up, what we're going to do is we're going to come back and we're going to look at this over here. This is the ACIS valve, and what it should do after startup is it should go like that a few seconds after startup, okay? So I want to make sure that that is happening. Then drive-by-wire test. All I'm basically going to do is just turn the accelerator ever so slightly, because as you could see earlier, literally, if I do that, I'm not moving the throttle. So if the engine revs up when I do that, then we know the drive-by-wire and the throttle motor, everything is working as it should do. Then we're going to go back into the OBD2 machine and we're going to check the oil control valve. So my little tool will allow me to test both oil control valves one at a time. So we'll start with bank 1, we'll do bank 1, and then we'll do bank 2. And it causes the engine to like idle really roughly as it advances and retards the cam. So you'll be able to hear that change in engine note to dictate that the test is going through, okay? Then what I'm going to do is I'm going to test the injectors and coils, and the way I'm going to do that is I'm actually going to unplug each injector one by one, and what I'm looking for is the engine to start misfiring the second that I unplug it, okay? What I have done on here, just as a head up, because I'm only going to have one hand, some of these really difficult to reach ones I haven't actually clipped back on again. So if I start it up and it misfires and you see me messing around, I'm just going to find the one that's causing me an issue to misfire because it's not seated correctly. But unfortunately, I can't undo the injectors with one hand. Most of them I can, but some I can't. Okay, so that's, if I start it up and it does that, it's not a fault. It's just because I haven't actually clipped the injector plugs in and I'm relying just them resting on there. Then we'll come back to the cluster and we're going to look at the tacho and we're going to look at the coolant temp, make sure that they are working as well, okay? And then lastly, we're going to go through the diagnostics. I'm going to show you what goes on there and I'm going to show you how else you can do diagnostics on this particular setup. So let's jump into the ignition on testing. So as I said, the first test is immobilizer removal. So what I'm going to basically do now is, let's see if I can put the camera down and still have you seeing the cluster over there. So let's just move the camera down like so. That's as low as it goes. Let me see if I can lean this at an angle. There you go. So you'll notice the check engine light come on as soon as I connect ignition, and you'll see the security light stops flashing. So I'm going to do that now quickly. Okay, so that's ignition on. You can see we've got check engine light, we've got battery light, and we've got oil light, and the security light has stopped flashing. Okay, so everything we wanted to test in the first little bit is perfectly fine. Last thing is the LED in the fuse box. So again, that is all lit up. Super happy with that. Okay. Now then, let's go over to the OBD2 machine. All I'm going to do is, it would have lost communication because I turned the ignition off. And I've just selected a very small amount of data to come through here. And what I'll do is I'll go into function, I'll go into system select. It's probably going to remove all my work there, but you can see it's picking it up as an LS400. So again, really nice, simple and straightforward. So OBD2 is plugged into our OBD2 port over there. Okay, so everything is working exactly as we would expect it to. So first of all, I'm going to go and do the active test for the fuel pump, and then I'll simplify the data down again for the rest of the test. So I just want to go into active test. And it says fuel pump relay and fuel pump. If you watch my fuel pump video, that will make sense. If you didn't, that's going to make no sense whatsoever. So I suggest you go watch that because it's useful information for you guys. Just so you know, we don't use the fuel pump relay in our system. Okay, and we don't have a fuel pump resistor hooked up either. Okay, so all I want to do now is turn the fuel pump on. Hopefully you can hear the relay click and you can hear the pump whirring away back there. I'm going to turn it off. And there she is. Okay, so as I said, the ECU is controlling the fuel pump, so that's why I can use the OBD2 machine to activate the fuel pump via the ECU, activates the relay, then turns on the fuel pump as it's running. Okay, I'm going to quickly reduce the data down to a bare minimum, otherwise we're going to be sitting here for ages with me scrolling down while we do the brake switch, the kick down switch, and the PWR mode. So you want engine speed, coolant temp, and then we want stop light switch, yep. And then we want kick down switch, yep. Power mode switch, yep. Fantastic. Okay, so that's going to reduce the amount of data, so also transmits quicker. The more data you have, the slower the system is. Right, so first thing we want to do is the brake switch. So we'll have a look over here and you'll see stop light switch at the moment is saying off. I'm now going to take the white with the blue wire from this plug. I'm going to provide it with 12 volts. And as soon as I do, you're going to hear the relay click. And stop light goes to on, let it go. Hear the relay click and stop light goes to off. Right, next up is kick down switch. Kick down switch is going to be yellow with a red, and that needs an earth. And as soon as I supply it with an earth, there you go, kick down goes to on, let it go, kick down goes to off. Next up is power mode, which is going to be my yellow wire, just my yellow wire over there. I'm going to supply that with a ground, and as I do, you'll see the power mode goes on, and power mode goes off. Okay, right, so some of you may see manual switch for the GS400s. Instead of moving from drive to 4, it moved from drive to manual. So only the GS400, the 1UZ-FE VVT-i, had the shift up, shift down functionality. So what you'll notice is when I'm using the ACIS cluster, when I go into 4, it's actually going to activate M for manual mode. They're the same thing, basically. It's the same signal that goes to the ECU. It just depends on which ECU what it does. Right, so that's that. Okay, so now I want to test all the gear selector wiring. So first thing I'm going to do is I'm literally going to disconnect all of the MPX from my little device because I need to get that out of the way. And I'm going to connect up the standard 1UZ-FE VVT-i ECU. So there is some compatibility between them. And as soon as I did that, you probably noticed that the park indication fired up on the dash over there. So you can see that says park over there. Okay. So all I'm going to do now is I'm going to turn the selector and I'm going to move through the gear positions, and you're going to see them changing on the dash there. So let's go. We've got park. Let's go into reverse. Let's go into neutral, into drive. You see there I was talking about? If I just move it a millimeter over, it cuts out the signal. So there's drive. And you'll see it skips and goes straight to 3. Again, if I move it a millimeter, I can lose the signal. And next up is going to be 2. Okay. Now I'm at the bottom of the selector switch. I cannot move anymore. That's all my mechanical movements, okay? So you can see it's selected every single gear there. So what I'm going to do now is I'm now going to provide L with 12 volts from 2. I'm going to provide 4 with 12 volts from D, okay? So again, probably not going to be able to see much what I'm doing here, but basically I'm going to take my red wire and I'm going to feed it to my yellow black wire, which is directly underneath it. And for L, for 4, I'm going to take my D, which is blue with a red, and I'm going to feed that to the yellow with the green, which is again directly underneath that on the plug. It's almost like we made it that way. Right, so now the change that we're going to see is because I'm technically providing L and 4 with 12 volts via their selective gear the correct way. So when I move from drive to 3, it'll cut the power, so you won't see 4 and 3 having power at the same time. So the ECU is working as it would a Toyota. So again, let's go through it. So we've got park, we've got reverse, we've got neutral. But now when I go to drive, it's going to skip drive and it's going to go to M, which is the same as 4. We're going to go to 3, and instead of going to 2, oh, hang on. Oh, did I push that out? Sorry, that just came out there, so that's L, okay? So again, L, skip 2, we're going to go to 3, skip, no, then go straight to 4, which is M, skip D and go straight to neutral, we go to reverse, and we go to park. Okay, so I'm happy with that. As long as your selector is plugged in and working correctly, you should have all those gear positions. Now, obviously, I do give you some wires, so I give you D, I give you 2, and I give you R, so you can check that that is working in your own way with like a little multimeter or a test light. Obviously, if you don't have anything that can translate MPX, you can plug in an OBD2 machine like this. This does actually give me all the gear positions as well, so I can physically see it via a tech stream or something like that as well. So there's many ways to get that information. I just have access to this that's lying around, so I can do it. Right, so that is the gear shifter wiring. Super happy with that, happy with everything. So all I'm going to do now is make sure that it is warm enough for the coolant temperature to reach on the gauge, and we're going to come back and we're going to do the test with the engine running. So see you in a second. Right guys, so we're back again for the test with the engine running. So you can see I've let the coolant temperature go up slightly. So you can see over there, I think it's about 45 degrees, but I can adjust that on there. So I probably adjusted it very low so the temperature shoots up even when it's quite cool still, okay? Right, so all we're gonna do now basically is recap. So start a circuit, neutral start switch. I'm gonna put it in reverse, try and start it, it won't start. Put it in park, it'll start. We're then gonna pop over to the engine, look at the ACIS valve, and that should turn down like that. Then what I'm gonna do is I'm gonna go over and I'm going to test the drive-by-wire circuit. So I'm just gonna then just rev the engine like that. You can hear the throttle working already. Then we're going to test the oil control valves with the OBD2 machine. We're going to come back and we're going to disconnect each injector one by one to hear it misfire, so we know that each cylinder is firing correctly. Then we're going to check the tacho signal, so make sure we're getting an RPM signal through there and that it goes up and down when we rev the engine. Coolant temp we've already done, and then we'll go through diagnostics on there. So when I start the engine, what you'll notice as well is obviously oil, battery, and check engine light will go out, indicating no codes on there as well. Right, so I'm going to put my ear defenders on. And as I said, I think we left the vehicle in park. I'm just going to check that quickly. Yeah, she's in park. So I'm going to move her to reverse. Right, so now she's in reverse. Okay, so she's not in park or neutral. I'm going to try and touch the black with the yellow tracer wire to 12 volts. And we get absolutely nothing. Right, we're going to move her back to park. And 3, 2, 1. Okay, there you go. Happy with that? You can see the ACIS valve has gone down. Super happy with that. Okay, super happy with that. Let's go over and test the oil control valves quickly. So we're going to do back one. Go to number 3. And let's do number 1 as the last one. There you go, fantastic. Okay, so every cylinder is firing as it should. Super happy with that. Okay, tacho. You'll see we've got a signal coming through there. We'll give it a quick rev. Super happy with that. And coolant temp is probably risen up from where it was originally because we're now on about 63 degrees. Okay, right. What I'm going to do now is I'm going to kill the engine. I just blanked off the intake there so that I killed the engine. Rightio. So what I want to do now is I want to do diagnostics. So you can see that the check engine light did go out. Okay, that's important to know because obviously there's no codes that are causing a limp mode. Otherwise the check engine light would be on. Now, unfortunately for you American guys, your ECUs are way more sensitive than ours, as you're going to see in a second. So first thing I'm going to do is I'm going to go to diagnostic trouble codes. Let me try and move this camera around so it's nicely on there. We've actually got 9 codes on this ECU right now, but none of them cause a check engine light or a limp home mode. Okay, so basically we've got oxygen sensor 2 and 2 for bank 1 and 2. So that's the ones that are after the catalytic converters. Now again, us JDM guys and European guys, we are lucky we can run these 1UZ VVT-Is with no secondary Lambda sensors. It does not cause a limp home mode, and it does cause the code to stay in the system, but it doesn't cause a check engine light or anything like that at all. So when you're passing an MOT in the UK with it, it would technically do it because it doesn't have a check engine light on. Right, the rest of the codes are actually rated just to the gearbox because we haven't got it plugged in. So we've got shift solenoid 1, 2, 3, and 4. And we've got SLU, SLT, and SLN. Now, obviously, all of those codes are going to go away the second that the gearbox is plugged in. More specifically, the solenoid plug, which is all of those codes relate to that over there. Okay, now then, you can read all of the live data and get all of your diagnostic codes from the OBD2 port, okay? Now, again, this is only for JDM and European guys. Sorry, USA guys. This was cut off from you guys. I'm not sure why. I speak to Toyota and Lexus about that. But basically, with these ECUs, we can read codes, okay, without even having a machine. Now, what I've done is I've built the ability to do that in the fuse box. So on the very older engines, you used to have that little diagnostic port on the engine harness and used to bridge TE1 and E1, okay? It's very similar in this case. We do basically the same thing, except what we do is we actually build it into the fuse box. So if you have a look in our fuse box over here, you're gonna see that there is an opening there that looks like there should be a fuse there, but there is no fuse there. That's perfectly normal. That is how we bridge TE1 or TC and E1. So effectively, all you're gonna do is take your little things over there. You can pull out any one of these fuses. You can actually do it with a paper clip if you wanted, to be honest with you. You don't even need to do that. But what I'm going to do now is I'm going to bridge these 2 terminals here. You see the check engine light goes off in both places and it'll start flashing. 1, 2, 1, 2, 3, 4, 5, 6, 7. That's 27. Bank 1 sensor 2. And then we got 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's bank 2, sensor 2. And you'll see there's a long pause now. And then it'll go back to 1, 2. And it'll just keep repeating those codes. Okay, so I call it the old school method. All right, you can read all the codes without that. With all of our harnesses, you do get a 2-pager detailing all of those codes that you can read up there. So for example, 24 and 31, 24 is intake air temperature, 31 is mass airflow sensor. You can tell how sad I am because I know off the top of my head. 21 and 28 are, 21 is bank 1 sensor 1, I think, and 28 is bank 2 sensor 1. So it'll tell you if the oxygen sensors are faulty as well. So in this case, the only codes you're ever going to get when you try and read that should be 27 and 29, and that's the 2 Lambda sensors after the catalytic converter. But again, doesn't cause a check engine light, doesn't affect performance, and doesn't change the way it runs, okay? Unfortunately for you American guys, as I said, you do need to use either the secondary oxygen sensors, or you need to fool the signal somehow in order to remove the check engine light. I can't remember what I did with the last American one. I think I just gave him the wiring for the secondary oxygen sensors and he put them in. I think he was in California, so he had to have all of that stuff in anyway. But yeah, that's it basically, guys. I know these end bits with the engine running and everything is so short, but that's because the layouts are usually really long, and that's where I give you guys a lot of useful information. This is more just to show the customers that, you know, everything is working as it should. Help you guys to sort of see how everything should work when they're wired up correctly as well. But again, all of our harnesses come with these instructions, not the testing sheet that stays here, but all of these instructions, all these wiring instructions gets emailed to you in a nice big PDF, along with all of the codes that you can read via that. I will always advise using the OBD2 machine. That is the best route by far, because it gives you live data, which you don't get through that. But if you are in a bit of a pickle and you don't have access to a machine, you got to check engine light on, and you can check exactly what the code is straight away without having to worry about plugging a machine in. Before I go, when you bridge those two pins together, or you move the fuse over, use a paper clip or whatever it is, you put the engine into diagnostic mode. And another useful trait of that is it locks the timing at 10 degrees, okay? So as you can see over here on your cover, you've got 0, 5, 10, and 15 degrees. I actually highlighted that. That's for changing timing belt if you guys are interested. And down here, there you go. I've actually painted white paint on this so you can see it quite nicely. So effectively, what you can do is bridge those two things together, start the engine up, locks the timing at 10 degrees. If your timing light works, just wrap it around the wires over here, and you can check your timing is at 10 degrees. So if you are a bit skeptical that maybe it's slightly a few degrees out, it's a good test. But do bear in mind, guys, that often these crank pulleys on the front here, they're actually got a piece of rubber in the middle, so they can actually move over time if they're very old. If yours is extremely old and bad, I would advise obviously replacing it with a brand new one, and that we don't have to worry about that particular issue where it's actually the pulley that's moved a degree or two out. Okay, but yeah, so that's it. And then when you're done, please remove that fuse, because if you do, you're going to lock the timing at 10 degrees. And I don't think I need to explain to you, if you lock an engine's timing at 10 degrees, especially on a naturally aspirated engine, you're not going to have a fun time. The power is going to be ridiculously reduced and so on. And also make sure that your ACIS valve is working. What you can do as well is on here, if you take a look at the wires on here, there's a white wire and then there's a white wire with a blue stripe. The white wire is 12 volts. The white wire, the blue stripe is ground. So in this particular case, black is 12 volts, white is ground. If you feed that to that while the intake is off and you don't hear that vacuum solenoid valve click, then just replace it while you have this off. It's a lot easier to do it then. And get it right the first time, because obviously if you're replacing inlet gaskets and all that type of jazz as well. Okay, right, so that is that. This harness is now completely done. Let's get this off to Germany in the rock crawler so they can start having some fun. If you guys have any questions, please feel free to ask below. As I say every single time, I don't know what you don't know. So if you guys ask me questions, next time we have a setup in where I can answer that question, I'm more than happy to do so. Obviously, my friend Calvin in New Zealand has got a range of videos with a load of in-depth information as well. So between the two of us, if you ask me a question, I might point you to one of his videos if he's answered the question thoroughly there as well for you guys. So basically, that's it. And thanks for watching as usual. And we'll see you guys again soon. Bye-bye.
Break, always fight, never quit, do it right, play the game, win it life, have no shame, there's no time, feel the pain, live the grind, I could change, in my mind, pick a lane, commit and climb, the only way to win it life, I never miss, that's fact, taking big swings, put your hand to the bat, put me in the ring, you'll go out in a bag, cause I sing what I mean and I bring it to the mad light, ain't got time to kill, I got time to feel, I took the red pill, I know life's short so